Hey everybody, let's go ahead and let's start the review. I'm going to take the questions right from the Google form that I posted and go over every one of them individually so that you guys know what's going on. Okay, now starting with the first one, we have an example of complementary angles, and we know that because there is this little box here in the corner that represents a right angle. Okay, so this is a 90-degree angle right here that we're looking at, and we have one angle that's missing. So now all it is a matter of just setting up an equation where you have x and you have another angle, 28 degrees, and setting that equal to 90. Now a lot of people, I know when they do this, they're just like, well, I'm just going to do 90 minus 28. Well, that's how you solve the equation anyway. Set it up like that, and then you get your answer. So, all right, so there's the first angle right there. That's what x is equal to. And if you want to be extra careful, and if you want to see if you did it right, just add them up and see if that adds up to 90, and it does. Now looking at the next one here, we have an example of angles that are supplementary. That means these angles here together, they make a linear pair. A linear pair, I mean, that's a line right there. Or that's a straight angle right there, meaning that's 180 degrees. It's 180 degrees in a straight angle. So what we have is now just kind of like what we did before. I'm going to set up an equation. So y plus the other angle, 41, should equal 180. Take away 41 from both sides, and we just figured out what y was, 139. And 139 plus 41 is 180 degrees, which confirms that we're dealing with supplementary angles right there. Okay, now this next one here is one a lot of people missed or didn't get quite all correct. You know, there's a lot going on here, so this is where I think it helps. I think some of you, when you're doing your math, you're just looking at a screen, I know, but it does help to write stuff down on paper or scratch paper or something you have nearby, and jot it down and just start writing stuff in, because that's kind of how math should be done. It's always kind of good if you write everything out so you can see what it is. So like for instance, this first bit of information right here, it says that angle AGB. Well, angle AGB is right here. That's describing that angle right there, AGB. That's angle AGB. The measure of angle AGB is 35. Now this is a true or false question. And so it's asking, you know, is that true or is that false? And what I see here is that there's a 90-degree angle. There's a 90-degree angle right there. So this has to be also 90 degrees because it's part of this linear pair right here, which is 180. And then all you have to do is just check it out. Does 35 plus 55 equal 90? And it does. So that would be true. Now the next one, it says an angle complementary to angle CGD. Now let me just go ahead and outline that. So CGD is that angle right there that I outlined or highlighted, I guess. And an angle complementary to CGD measures 90 degrees. Well, if that angle itself, that angle already is 90 degrees. Complementary angles mean when you add them up, when you add two angles up, they equal 90. So if one of the angles is already 90, well, what does that have to be so that the other angle equals 90? Well, that would have to be a 0-degree angle, and that does not exist right there. If it's 0 degrees, it's just not an angle. It's nothing. It's not even there. So this is a problem that was false. I know some of you might have read this problem and thought, well, you know, complementary, I was taught that complementary means 90 degrees. Yes, that means if you're adding them up. But if one angle is already 90 degrees, well, there's nothing left to add to it to make it equal to 90. So it is impossible to have two angles that would make 90. An angle supplementary to CGE, let me outline that one. Now CGE is right there. So an angle that is supplementary to that angle measures 55. So here's the thing. Now this angle, this one's a little tricky. Now this angle right here is 55 degrees. Now notice that is right across from this angle right here. Now those angles right there, what relationship are those angles to each other? Those are vertical. All right, those are vertical angles right there because they share a vertex and they're directly across from each other. Remember, it has nothing to do with being vertical from each other. It has to do with sharing a vertex. What do we know about vertical angles? We know that vertical angles are equal. I know this problem really doesn't mention anything about vertical angles, but knowing what vertical angles is important to understanding whether it was supplementary to 55. Okay, so now I'm going to look at this angle right here. Now, if I look at this angle, that angle is supplementary to this angle right there. This is 55 degrees. If that's 55 degrees, we want to know if it's supplementary to this angle right here. Is it supplementary to that angle? And I would say yeah, because those are a linear pair right there. So the answer to this one is true. Okay, on this next problem here, this is another good one where you want to probably write it out or sketch it out on your paper and just kind of see it. I think it helps if you write it out and put some numbers on paper and work with it so that you can just see with your eyes what's going on and see what's going on instead of just looking at your computer screen. Right here, it states that the measure of AGB. Now the measure of AGB, let's go ahead and outline that. AGB is right here. That's a 90-degree angle right there. So I'm going to put that in there. So that's 90 degree. Now what it's saying is that that angle is equal to 180 minus the measure of BGC. Now let's see, BGC is right here. That's where BGC is. The measure of CGD. That's right there. So now if this is 46 degrees, right there, if that's 46, this has got to be 44 degrees because those are complementary to one another. So that angle right there is 44. So now I have some numbers to put in here. So we've got 180 minus BGC is 44 minus 46. And let's see if that works. What is 180 minus 44? Well, 180 minus 44 is 136. And then what is 146 or 136 minus 46? And you get 90. And that matches what's right there. So the answer to this question was true. The next question says that BGC and the measure of CGD, well, BGC is right here. So here's where BGC is right here. That's where that is. And CGD I'm going to outline CGD right there. And that definitely looks like, and not just looks, we know for a fact that it is complementary because there's this little square right there in the corner. Sometimes that's kind of important in geometry to not just look at something and go, oh, it looks like it's 90 degrees. You have to kind of go and base it on the math and the numbers that are there that are showing. And then right here it says the measure of, looking at the measure of DGF. So there's where DGF is equal to the measure of DGE minus EGF. Now what I'm going to do is I'm going to put some kind of like hypothetical numbers in here, and DGE, angle DGE is this angle right here. Angle DGE is this angle right here, which it doesn't have it directly in it, but it has a square right here, which means there's a square right here as well. You can kind of put a square everywhere where there's a right angle and there's intersecting lines, but you got that. So that's a 90-degree angle. And EGF, now let's just pretend EGF, I'm just going to make up a number. Now it's not vertical from 46, but let's say it's about, I don't know, let's say it's 30 degrees or 40 degrees or something like that. I'm just going to make up a number. Let's just say I put those numbers in there. Now if I do the math here, now 90 minus 40 is 50 degrees. Okay, now I just made up some numbers here. Really could have put in 41, I could have put in 50 degrees, I could have put in, I guess, whatever I wanted to. Let's see. Now, does that match this answer right here, DGF? Now, DGF is obviously obtuse, and it doesn't even matter what the angle is. It's obviously obtuse. So does obtuse angle equal to 50 degrees? No, obtuse angles are greater than 90. So this tells you right away that that is a false statement. Now this problem right here and the next one, this is where I think some of you guys got confused, which I would totally understand. The wording of these was terrible. Sorry, but I think the workbook I copied these from is terrible. I think this part of information right here should have been just left off. It should be in the figure below AD and BE. It should be just R perpendicular. That means they're a right angle. They're 90 degrees. I think that's how it should have been stated, and I'll make sure that doesn't happen on your retake. Sorry, I totally understand. So I'm not going to count that if you didn't figure that out yourself. But yeah, there's no way for all three of those segments to intersect each other and also be perpendicular. That's just not going to work. Okay, so again, now this is where it helps if you kind of sketch it out and just see it, just put some numbers in yourself and just kind of get a good idea of what it looks like. If you're trying to do it all in your head, it's going to be difficult. So angle EOF, EOF is right here. So angle EOF is 33 degrees. So that angle opens at 33 degrees. Angle AOB, which is right here. Now that definitely looks like a right angle, but again, you can't assume right angles unless you see a 90 degrees in there or you see a square in the corner. You can't assume it. So it's 88, which is really close. It's probably, if an angle is 88 degrees, it's probably going to be hard to tell just with the naked eye if it's 88 or 90. Sometimes it's really easy to mix those two up. So that's 88. So this question, now that I filled that in, this question is asking, what is the measure of angle COD? So COD is this angle right here. So we're looking for that one. Now the thing you might want to recognize is that it is directly opposite, directly across from this angle right here. And now that I kind of highlighted that, you might now see what's going on. What kind of angles are those? Those are vertical. And vertical angles are equal to one another. Right? So if you can figure out what this angle is, right here, if you can figure out what that angle is, well, that's going to be vertical from angle COD. So that will tell you indirectly, I guess, what angle COD is equal to. Okay, so now to figure out this angle right here, what you're going to have to do is look at this angle right here. Now that's a linear pair, or not, I shouldn't say a linear pair, but right here, that's a straight angle. That's a straight angle. So we have, and I'll just call this angle N, but we have three angles. We have 33 plus angle N plus 88, and we know that that equals 180. So now I'm just going to put all this together. So 33 plus 108. All right, so I get 33 plus N plus 88 equals 180, and then you're going to get N plus 121 equals 180. Take away 121 from both sides, and then you're going to get N equals 59. So if N equals 59, so does this angle right here. So the measure of COD is also 59 degrees. Now for this question right here, question 6 has kind of the same thing going on, and again I have the same mistake or typo in this workbook problem. So AD and BD should say are perpendicular. I don't know about that third one. That doesn't make any sense. So sorry about overlooking that. It totally is confusing. But we have pretty much the same information. It says EOF is 33, so same angles from before, and we have AOB is 88. All right, now we're looking for this one, we're looking for a different angle though. We're looking for the measure of angle DOE. Now DOE is right here. Now you'll notice that that angle is directly vertical from this angle. They share this vertex right here. They share that vertex and they're directly across from one another. And what do you know about vertical angles? Vertical angles are equal. So that was an easy one. That was 88 degrees right there, because that's directly across from that angle. Vertical angles have the same exact measure every time. You don't need to get a protractor out. You just need to know that that's how vertical angles work. Okay, and this next one here, we've got two angles that are complementary. And a lot of people think, some people tell me like I'm spelling complementary wrong, but when you're dealing with complementary in terms of geometry, not complementing somebody's appearance or something like that, but if we're talking about complementary angles, there's an E there. Anyhow, all right, now complementary angles add up to 90 degrees. So I'm going to set up an equation where I have both those expressions, 3x plus 38. You don't have to put them in parentheses, but I'll just go ahead and do that. Plus the other expression, which is just a lone 10x. And then we're going to make that equal to 90 degrees. And this is where your algebra comes in handy. Put your like terms together. 3x and 10x makes 13x. Do not add 13 and 38. Do not make that into 51 or anything, because those are not like terms. So now it's a matter of just doing inverse operations, which means we're going to take 38 away from both sides. So that's your first step. And then rewrite the problem. Whenever you guys do equations, it's always important to kind of rewrite it. If you're trying to do all this in your head, it's going to be difficult. So you got 13x equals 52. And now it's down to a one-step equation, which means we're going to divide both sides by 13. We just figured out what x was. So x equals 4. So that's one answer right there. That's going to tell you that's 4. If you put 4 degrees, it's also okay, but you just have to put 4. Now the second part of this question is, what is the measure of the largest angle? Now the largest angle, now I know it looks like it's right here, and it is, but don't always assume that. So solve both of them if you're not sure. But you're going to put in 4 for x. 3x does not mean 34. It means 3 times 4. So you got 12 plus 38 equals 50. And that seems to match up the other answer. If we did 10 times 4, that's 40. And what does 40 plus 50, what does 50 plus 40 equal? Yep, that equals 90 degrees. So the measure of the largest angle is 50 degrees. That's all you had to do. And this last one here, same kind of setup here, but except for the fact that we're dealing with supplementary angles. All right, so they have a sum of 180 degrees. That means 2 or more angles that have a sum of 180 degrees. So the first thing we're going to do is we're going to solve for x. So the first expression, 12x plus 12, plus the other angle, which is 10x plus 33. And we're going to set that equal not to 90 this time. We're going to set it equal to 180. Now put like terms together. So put the x's, add x's with other x's, add constants with other constants. So 20x plus 10x is 30x. 12 plus 33 is 45. Set that equal to 180. Take away 45 from both sides. Now we're into the part of the question that we're going to do inverse operations. Those cancel each other out. So now you have 30x equals 135. And then divide both sides by 30. Now here's where your calculator comes in handy. And I didn't say anything about not using your calculator, but you're allowed to. And if you use your calculator, you get 4.5 or 4.5. So that's what x equals. So we just solve for x. Now this question is asking us to solve for the shorter angle. Now the shorter angle is 10x plus 33. But I'm not going to put x in. We're going to put in 4.5. All right, 10 times 4.5 is 45, and now it's 45 plus 33. And 45 plus 33 is 78 degrees. So the shorter angle was 78. The other angle is going to be, what is that, 102, right? Because 102 plus 78 equals 180. Okay, so that does it for this review. I'm going to go ahead tomorrow and post a very, very similar looking angle quiz. It'll look just like this, except it won't have those errors in it in terms of the language of the problem, but they should be very, very similar. Make sure when you guys take the quiz, though, that you have some scratch paper handy, you have a calculator handy, and you're writing stuff out. You're not just looking at your screen and trying to do it all in your head and put all that together. Sometimes that's when errors happen. And just write it out. It's good to see it. So hopefully this makes its way to you, and hopefully you got something out of this. Maybe you didn't have to listen to this whole thing, but you just went to the problems that you needed help with, and that's fine too. All right, so everyone have a great day. See you later.